So we're familiar now with creating a actor C++ class, and from that class deriving a blueprint class. So we have our floater BP here, and in our floater blueprint we have our category floater variables, in which we can see our world origin, which is not editable in the class default. We also have the initial direction, which is editable, and we have these booleans should float and initialize floater locations, and we saw in the previous video what those did based on the logic that we scripted in the C++ class. So now we're going to look a little bit more into actors, and in particular we're going to take a look at the collision or lack thereof that we have set up for our floater BP. So our floater BP has this static mesh property that was a variable in C++, and we can set the default value for this here in the blueprint. And what we're choosing here is the icosphere, and the icosphere is just this FBX that we imported. So if we go back to mesh tools, we can go to icosphere. Let's double click on that, and in this mesh editor we have collision, and if you click on that you'll see checkboxes for show collision, and you have simple collision and complex collision. Now if you click the checkbox on simple collision you won't see anything, and that's because this FBX file has no simple collision. If you click complex collision, then suddenly the outline of the icosphere is visible in a sort of blue outline, and you can see that this is showing you the complex collision for this mesh. And a complex collision for a mesh is typically the mesh itself, and if we use the complex collision for most meshes, it would be too computationally intensive for the engine and it would slow your game down. And so for this reason, oftentimes a mesh will have a more simple collision with less polygons, and that will be the collision that is used by the physics engine when it comes to simulating physics. Now, as it stands, our icosphere only has complex collision. It doesn't have a simple collision volume. Now we can add a simple collision to this mesh, and there are several ways to do that. If we go up to collision, you can see there are several options. One is add box simplified collision. If you click that, then you'll see that a box is now visible and it's in a green outline. This box simplified collision is something you can use for basic collision to make it easier for the engine. Doesn't have so many polygons to compute when it's doing the physics equations. Now notice I clicked on the box and a widget popped up, and that's because the box simplified collision is editable. You can actually alter it. You can move it around relative to the mesh. You can reshape it. If you hit the E key you can rotate it. If you hit the R key you can scale it, and so you can totally manipulate this into something that is more tailored to what you want. Now we can go up to collision and click remove collision, and that will actually remove that box simplified collision. And there are other options here as well. You can use add sphere simplified collision. This gives a sphere shaped collision. Let's remove that. You'll see also you can use 10.x simplified collision, and this is a particular algorithm that takes the geometry and computes a simplified collision that approximates sort of the overall shape. So if you click on that, you'll see that this is what the algorithm comes up with. It almost looks like a cylinder. You can remove that one, and you can go down to 18, and this has more polygons, and you'll see that it better fits the shape of the icosphere. You can remove that, and you can go to 26 simplified collision, and you'll see that that is even more accurate, although it doesn't fit the contours of the mesh perfectly. So you can go ahead and remove that. And for now, let's go ahead and again add box simplified collision. And so we can see what this looks like with a box collision. So we'll save that. And we can go back to Floater BP and click on Static Mesh. And in Static Mesh, we can scroll down to where we see Physics. And in Physics, we have this checkbox for a Boolean variable called Simulate Physics. And if we check that, that tells the engine to simulate physics for this particular static mesh. There's also an Enable Gravity Boolean, which is by default set to true, and that's ignored if Simulate Physics is off. But if Simulate Physics is on, then the engine will simulate physics for this particular object. You can also use this mass override. If you check that, then you can override the default mass for this particular object, and that will also affect how physics is used in the engine. There's linear damping and angular damping. These slow down movement for translating and rotating respectively. But for now, we're just going to have Simulate Physics checked to true. We're going to click Compile and click Save. And we're going to go back and we're going to delete 3 of these floaters. And we're going to leave one of them. And we can come down and hit W to get the translation widget. And we can bring this up above the ground like that. And let's go ahead and get our player start and drag it down to where we are next to the actor. And let's hit the E key and rotate it so that we're roughly facing towards the actor. Now remember, as soon as we hit play, this particular actor has in its floater variables category, we have some parameters that we set up in C++. One of them is initial location, and we set that to be 100, 100, 100. That's going to be where the engine places this in begin play. Well, let's click X here and take a look at its current location right now. It's 200, 100, negative 340. So let's scroll down to floater variables and let's put that at the location it's at right now. So 200 for the X, so we'll go down and put 200 here in initial location. Then we have 100 for the Y and negative 340 for the Z. So Y is 100 already and negative 340 for the Z. That way when we hit play, then our begin play function will use set actor location and set it right there where it is. Okay, let's go ahead and hit play. And there it is, and you'll notice that physics has this actor falling down and bouncing off of the floor. So go ahead and click on our player start, drag it back a little bit so we can see a little better, and click play. And there it is. It's got a physics simulation going on, and you'll notice it's still being pulled in a certain direction, and that's from, if we go back to Visual Studio and go back to floater.cpp and look at tick, we have this if B should float, add actor local offset. Now that is still being applied because B should float is actually set to true. Let's go back to Unreal Engine and click on our actor here, and in our details panel in the search box type float, and you'll see this should float. It's set to true, so we can uncheck this and click play, and you'll see it just drops straight down. There's no add actor local offset being applied here. So let's go ahead and hit stop. Now one of the things that I want you to notice is that it's falling down and it's balancing on the tip here of the icosphere, the bottom tip down here, and realistically that would actually tip over and it would fall over. But remember, we're using a box for our collision here, so it's staying up, because if we go back to the icosphere, we'll see that this box is actually what's being used for the collision. Now we can choose a different type of collision. Let's use this add 26 dot simplified collision, and that looks quite a bit different. Let's go back into the world here and click on the actor, hit E, and let's actually rotate it a little bit so it's not exactly flat. Now we can hit play, and you'll see that it sort of, rolls over a little bit. It's not quite realistic because, again, this collision doesn't quite fit the mesh, but it's a little bit more realistic. We can remove the collision and try any other type of collision on here, like capsule. That's a different kind of collision. Let's go back and give that a try, and you'll see it behaves kind of strangely. So that's another type of collision, and you can experiment yourself and use what you feel is appropriate. So let's go ahead and remove that and put it back to box simplified collision, and we'll just use the box for now because this icosphere is just a kind of tool that we're using to get to know the functions. Eventually we're going to get some real game meshes in here that look a bit more like something we're going to want to use in a game. So for now we're just going to use this. So go ahead and click save, and we have our actor with the box collision. We can hit play, and you'll see that it's really just behaving as if it's just a box, and so we understand why that's happening, so that's okay.